Hi guys, very good morning and welcome back to our YouTube channel. So today we will solve our day 7 questions. So we have already passed 7 days and now it is of day 7's, like 1 week has over till now. Yeah, so let's understand the today's questions. So what we have at on today's plate. So the question states that you are given a zero indexed string blocks of length n where blocks of I is either W or B. So we have given a blocks of size in, so the array or string is given to us, and this string is only contains white or blue values. W stands for white and B stands for black. W stands for white and B stands for black, representing the color of the ith block. The characters W and B denotes the colors of white and black blocks respectively. Now what is given, you are also given an integer k, and which is the desired number of consecutive black blocks. So k basically asking us to hold a value in the blocks which k consecutive black blocks, right? Now there can be like black white black white black white, and this sequence is going on, and let's suppose k is given us as 2, then too we are not able to say that there is exist a block of size k where k consecutive elements have color of black. That is not possible. So to overcome that problems in that question, what in the third line it is given that in one operations you can recolor a white block such that it is becomes a black block. So in one operations we can recolor a white block and to make it as a black block, so that like we can satisfy to maintain a k consecutive black block elements, right? Now what we have to return now, so now we have to return the minimum number of operations needed, which operations? The operations that we have just performed earlier to change a color of white block to a black block such that it is maintain a k consecutive black block group, right? Needed such that there is at least one occurrence of k consecutive black blocks. So I guess you guys got the questions, right? So we now let's understand on the question. So on that question, n is given to a range of n black blocks, and our n is given to be 100. So the size of this array or string what we are carrying is can be 100, and blocks of I is either W or B, and k, which is basically asked for k consecutive black block elements, which is should be always boundary of n. So that is never a case like your size provided block size is 4 and they are asking to build a k like k equals to 7 or k equals to 8 or k equals to 9, which is greater than of my block size. That is never possible. So that is clearly stated by the constraint 3. Now as per the constraint, we have few observations, like what we can say. I have solved it like 3 approaches. First approach, that is like seeing the constraint, and although it is an easy tag question, like if you are solving it on big of n square time complexity, then that is obviously a easy question. But again, like you have to identify the patterns and then solve it, and it is not an easy question. I have to say it is more than an easy question. It is definitely a medium level question, and I have solved this question if your constraint is like in the range of 10 to the power 5 also, or 10 to the power 6 also, then on that case your solution would work, which we are going to propose. Yeah, so we have 3 approaches of that question. So the first approach that I have written here is the DP approach. I think DP approach because as per the constraint I easily saw here a like choice things are coming. So choice basically if a particular, so what we have options here. So if we are trying to maintain a k consecutive black block, so what is our option? So we can what open if it is a black block already, so we can't do anything on that. And if it is a white block, then we can turn it out as a black block, or what we can do, or we can skip to color it to a black block, and we can consider there is a segment happen. So let me just quickly explain you guys. So sorry, this one. So let's suppose we have some white, black, black, then again black, then white, then black. So when you are standing at these particular points, this particular white block, so what is the option you have? So let's suppose you have till now k equals to 3, because you have considered 3 consecutive black block till now points. And now if you perform an operations on this white block, so when you are standing at this particular block so what is the option? So if your recursion is like on your blood, so your recursion should be on your blood. Your recursion should be as thorough as that you should be able to write the recursive or choice based recursive code in like few 2 to 3 minutes at max, and then memorizing it again 2 to 3 minutes, and in max to 5 to 6 minutes you are able to solve the entire question. So your recursion should be the fundamentals of solve any DP question. So if you are not on the path of solving the recursion question very frequently, please do, because recursion is the base of every difficult question. DP, BFS, DFS, graph, tough problems is based on the recursion only. So please strong your recursion. That is mandatory to like solve any DP or graph related question. Yeah, so now I am just giving you a taste of how recursion is going to be work. So when you are standing at point W, so that is a white ball. So on that particular point you have choices. You can either color, you can either turn this, you can either apply a operation to turn it as a black ball. So on that case your consecutive is on next recursion call is going to be k plus 1. So not make it k, then let's name this consecutive. Like till now you have consecutive this, and if you are turning these operations, then you are going to consecutive plus 1 on the next set of iterations. And what we have performed one operation, so our to next iteration go will have one operations performed because of turning it, so that is going to be add 1 in our answer. And then for the next recursion call, our consecutive is going to be our consecutive what we have till now on this point is going to be plus 1. And if we are not turning this block to be black, right, then we are considering it as a white only. Then what is the choice? Then we are calling our next recursion function for next index. The first element should be our index only, so we are just going to the next element. So next elements means we are moving to here, and what we are doing, we are again like how many because we have not we have just saw white ball, but we are not colored it to black. So what is the basically the consecutive black balls? If we are not turning a white ball to a black, and if we encountered a white ball, then the consecutive is again reset it. Reset means it is going back to 0. So that is our next function call. So now this can be, our answer can be minimum of either of these function, this or this, minimum of either of these two functions. And so that is the case when we have the blocks of I equals to a white ball. Then on that case, and if we have to have the choice things, but if our blocks is, let's suppose blocks of I equals to a black block is there, so on that case too we don't have any choice, right? Because then on that case for black things we are not performing any operations, we are good. We are going to next index, and we are basically making our consecutive count as plus 1, because we have, what is the last consecutive counts we got, as it is a black block, what is the consecutive count including this particular block is last plus 1. Nothing. As simple as that. And yeah, if it is a black block, then we don't have choice, you can return. And if it is things of white block, then we can minimize these things and we can return. And base case I will tell on the question itself. So I think this recursion state change is very clear to you. Yeah, so that is the main funda of this particular, how your next choice is going to be determined by your current position. Yeah, now let's jump on the question. I can explain from there the base case and other things. Yeah, so I have created a DP of size, that is a standard template. So you guys, if you solve the question of DP, then you guys are very familiar of that. Like we have to we have to store some things in a basically a block or basically a storage memory, and basically these functions can be pre-computed. To reuse the answer of pre-computation, we are storing what we have calculated so far, we are storing it in a DP matrix, DP list. What, as per your question, that DP state is going to be defined. So here we have taken a 2D grid of size I n cross n, correct? So n cross n means that is 100 cross 100, that is of size 1000. Yeah, now let's write on the understood the base case. So when we are starting our DP from very start index of 0, and what is the consecutive element so far we have seen, so that is also 0. So from there we are iterating till end, right? So on iterations, what we have at, so if we are standing at I equals to n, that we have already done the computations of the entire array, and if entire blocks, and if our consecutive counts is equals to k, like we are able to build a k group black blocks, then though we are good, we are returning 0 from that particular point. So that means we are standing at very last elements, like out of the boundary of our black blocks, and standing on there we are able to build of k size black block. Then can we say, like, from these particular points we can return a 0 as an operations. We have to return the identity. The identity should be 0, because if at a, like, if you are standing at the out of the boundary of that particular elements, and if you are satisfied of making k consecutive black blocks, then standing on that particular point, do we need any extra operations? No, right? No, right? But standing on that particular index, if we are able to satisfy our answer, do we perform any extra operations? Because we are greedy also at the same time. We are not, we have to minimize our operations. So we are able to build k consecutive elements. Then why we are going to add something on our answer? So we can return as 0 from there. So we don't need any further operations. But if it is not so, then we are returning a max value. That is like very high, 10 raised to the power 9. So because we are stating like what is the choice you have taken by the explanation that we did on the one note, by that we are not able to build of k consecutive elements altogether. So on that case we are returning max, very max things to our answer. So if it is stating to minimize your answer, you have to return a very max things, because on the recursive calls, when you are getting a very max things and there is a feasible answer, another recursion call giving you a feasible answer, then that is going to be taking the minimize of them. So we have to provide a invalid or which is not in the constant, something like this, so that another function call which is able to calculate our answer, which is going to cut these things, so this max is going to be cut by a successive calls which is able to build k consecutive elements. And as per our constant, it is always possible, because k is in the range of n only, correct? K is in the range of n only. So turning the, let's suppose every bit is white, every block is white, and you have to make a block of size k equals to n, you have to make a consecutive n size black block. So on that case, what is the worst case? So that is the worst case. So on that case, you are landed on marking every white block to a black block, correct? So that is the worst case. So on that case, we have to return a very high thing, so that if you are, because there is a choice, right? When we saw a white block, then on that case we are either turning this black block to a white block to a black block, or we are going marking it as it is, making it as it is, and we are changing our consecutive count to 0. So like this way some of the recursive call is not able to build the consecutive elements of k size. So that is a not correct recursive calls, that is not a correct possible choices we are able to we have taken, so that we are not able to build. So on that case, what should be our answer? That is could be a very max things. I think this is very intuitive. If you done recursions in depth, then you should be like top of that, like you are very easily getting these things. Yeah, but yeah, like as per different audience, I am just trying to explain it as best as possible. But if you think we need to make a separate video of recursion things, then please make a comments out. We will definitely happy to do that. Yeah. Let's move ahead. So if we are able to build of k consecutive elements, then on that case also we can return 0, because no matter what is the index we are standing, and we are stating that we are able to build k consecutive elements, then fine. Then what should be the return from there? We can return a 0 from that particular point itself. Yeah, that is also very straightforward based conditions. And the third conditions is what I have stated, like drawed on the this one note, and there it is stated, if it is a black block, then though we don't have to do anything. So we can just move our we can make another recursive calls, and we are basically going to the next index, and we are increasing our consecutive counts. And if that is a very standard DP memorization things, if we know, you know, and if we don't know, then you have to learn. There is no alternate there. And yeah, if you want, I need to start a separate videos on the DP, or at least recursions. If you guys make a comments, then recursive, if you should be go step by step. If your recursion is fine, then only you can go with the DP, because if you write the correct recursions with the correct changing parameters, converting to a DP is like 2 to 3 minutes work. There is nothing to do. So yeah, please make a comments if you need a details playlist on the recursion. So as per the comments or as per the feedback, so we'll happy to start that. Cool. And if we got our answer in our DP variables, then we are fine. We are returning from our DP itself. And if it is not, then the two function calls that I have mentioned you on the one note. So one call is going to be, we are turning this white block to a black block, and we are going to next index, and our consecutive count is, what is the consecutive counts we have so far, plus 1. What is the consecutive counts we have? Plus 1. That is our next recursive call. And if it is not, then we are making a standard next helper calls with next index, but on that case we are changing our consecutive counts to 0, because we didn't turn the white black block. Yeah, that I have mentioned already. And if it is so, then before returning, just stored it to our DP, because that state can be again asked in the further recursive call. Then you don't have to jump on these things. You can directly return from this particular your DP matrix altogether. Yeah, and this all about that recursive code, and the time complexity of this is, like, I have to say of big O of n square. Sorry, the time complexity of big O of n square, and space complexity also something of big O of n square. Yeah, why time complexity is big O of n square? Because there are two changing variables, I and consecutive, and I can go at max n, and consecutive can grow at max of k. So I can say that is of time complexity can be of n into k at max. If k is smaller than n, then somewhere there is an improvement. And this also we can make as n cross k, because here also I think this can be, should work with k plus 1 also, this DP things. Yeah, that is a type of quadratic solutions, but yeah, what it is, but your recursion and DP is going to be nurtured very highly with this person. Yeah, and second approach is a brute force with two nested for loops. So I basically not written the code, because that is very intuitive, like, but that is needed to understand your third sliding window. That is the most optimal approach. So let me just quickly explain how the brute with nested loops basically work. So if I can consider these particular things, so what we have something, can we write a text? text, where is text things, not sure. हाँ, अरे यार लिख ही लेते हैं, क्या ही है इसमें। WBB, WWBB कहाँ चल जाता है। WBB, दिन क्या था, then we have WWBB, WBW, VMW, WBWBW, ठीक है। तो now what we have, so if you are observing this question a little bit carefully, so then you can see that if we are standing at particular these white elements, then we have, can we figure it out, we can, यार इसमें कर तो सकते बहुत कुछ, हो उतना कुछ नहीं है। चलो तो व्हाट वी हैव नाउ, if we are standing at particular this w elements, देखो फिर से घूम रहा है। If we are standing on this particular w elements, then we can start, we can iterate, there is an one I loop that is start from here, and we can iterate from this part, we can start a j loop from I itself, and we can move it till of size k, we can move it till of size k, and we can check this particular I to k, how many, let's suppose our k is, let's suppose 1 2 3 4 5 6 7, k is equals to 7, ठीक है। now 1 2 3 4 5 6 7 till this point, now when we are moving our starting on that particular I, we are moving till this block. Now if we have a k 7k consecutive block, then we can just check how many white elements we have, how many white, 1 2 3, so we have 3 white elements. So if we are going to mark this particular white elements to a black elements, can we say we are able to build one of our answer? So this particular block, can I say our answer for this particular block is 3? We can, right? So we are just turning the white block to a black block, and we are able to make a size of 7 consecutive black block. Now next what, now next if we are, now we are moving our I pointer to next from this particular b, and again we are do same things from this particular I, we are again consider a block of k consecutive elements, we are again start our j pointer from here, and we are again iterate till this particular point, and we are again check how many white block on that particular segment, and again we are moving our I pointer, and again we are going to check how many k pointer till this particular point. Like this way we are keep on iterating. So your I loop is going to be iterate of n times, and your j loops is going to be iterate in a k times. So your time complexity is boiled down to n into k, which is same time complexity what we did with the these things. What is the name? DP, dynamic programming recursion, right? So that is the second approach, that is very straightforward, and there is no super logic on that, but the super logic is going to be come from that particular observations. Now let's observe. गंदा तो बहुत हो जाता है, let's write it again somewhere. ये भाग गया, what we have क्या था यहाँ पे, insert, so we have some, draw से हटाते हैं पहले, short turn off कैसे होता है, add pane, ठीक है। now let's consider a block of the same things like what we have till this points, not able to do so, why, that is control Z, I am just making it to the original state, or is there any option, the draw is okay. Wait guys, let me just point out my charger. Sorry, we are back with the charger. Huh. So basically what I try to mention here na, so let me make a copy of this. That should be super helpful then to our explanation purpose. Nice. Now what do we have at? Now let's go to the full screen again. Then go to the अभी यार पेन छुपा लिया इसने. Now what we are basically doing when we are standing at that particular index, when we are standing, select how, when we are standing at that particular index, and from here let's suppose we are looking till that particular points of k, so that we for sure have to iterate. There is no options of skipping these things. We have to consider these things. But so we have already first go, we have considered a block of k size elements. Now we have two things. We have our, let's suppose, operations needed till now. What is this? This is the number of white block we have of this first this k segments. So that is something like of white block, how many? 1 2 3. Now when we are moving, so on the brute force what we are doing, we are let me just scroll up a little bit. So what we have on that first go, so we are again moving our I pointer to this particular block, and from there I am again consider a k loop. We are moving our I here, and from here we are again starting a j loop till this particular k. But do you think can we skip these things? Do you think? So there is a concept of what? Control Z, Control Z, Control Z, Control Z, Control Z, Control Z, Control Z. Cool. Now there is a concept of sliding window. So there are two types of sliding window. One is fixed size. If you know, only know, but if you don't know, you have to read it. There is no options. You have to be mastered of this topic. A very good, because these are like heavily used topics and heavily important topics for that interview. Yeah, that is a fixed size, and another one is a variable size. But yeah, if you don't know, then I will explain the fixed size with this particular, because fixed size is going to be state for this particular question. So I'm going to explain the fixed size, and you will get a very good grip on that particular question altogether. The fixed size, you are able to solve on the most of the question if asked on the fixed size sliding window. Yeah, but if you want I need a separate dedicated videos of this particular topics, then please make a comments accordingly. Then only I can do prioritizations of that particular topics, because without your need or your basically likeness, I am not able to go in. I have start the 100 days coding challenge on my own goal, but if you want these particular topics need to be make a separate videos to you guys are getting better clarity on that particular topics, then please make comments. Please do making comments, then only I will as per the comments I am going to prioritize these things. Cool. Sure. Then move with our explanations. Then what is needed? So if we have a k consecutive elements, then what is our next block? What is our next valid block? So the first valid blocks is this. The next valid block for which we have to consider our answer, that is starting from this B and it is going to this W. So what is changed actually? So do we need to iterate again from B to this W? Do you think so? No, right? Because we have already our answer of this particular segment. We have already have our answer of this particular segment. What is the extra things we have added? We have added another extra W. And what we have to reject it out from that particular last calculated answer? This particular W. So we have just adding one of these extra things, and we are removing one of the extra things, one of the pre-computed things from the very left of the sliding window. We are going to digest. I'm repeating these lines because that is actually the backbones of this fixed size sliding window. So please try to digest these things. That is what you need to understand. What we need to throw it out from our fixed size sliding window, and what we need to incorporate the elements to our fixed size sliding window. That is what, if you get a grip on this, then your fixed size sliding window is done. Nothing more than that. So I am repeating these lines. What you have to incorporate, this particular W you are going to be incorporate. What you throwed it out from your calculations, but this particular W is going to be thrown out from your particular answer. So from your next cycle, what is the number of so what we have? So from that, कहाँ पे एक 3 लिखे थे ना हम लोग, हाँ, here we have written 3 na. So this, considering this first block, how many operations we needed? Operations needed, we have 3 tha na. So 3 means there are 3 white blocks were there. And for the next case size sliding window, what is our operations needed? We have thrown one W from our answer, so that means our operations is going to be minused out by ones, and we have added one things to our operations, another one W to our operations. Correct, agree, right? Then our operations is going to be minused out because we have thrown one W from this hour, that is for throwing out by left pointer, and that is of adding one, that is adding for right pointer. Correct? And so that is if it is a white block. And if it is a black block, then think about logically, if it is a black block, then do we have to do anything? We are going to add one black block to our answer. So then to fine, if we are moving our right pointer and if we have encountered a black block, then to fine, then do we need to do any operations for black block? We know, right? So for black block, to incorporate our right pointer, we don't have to do any operations. And if our black block is to our left pointer, and if we try to omit it out our left pointer, do we have to do anything? No, right? Because on our left pointer calculation also, where it is the left pointer is lying currently, on that particular also, for black block we are not doing anything because that is a black block. So for black block we are not doing any operation. So there also we don't have to do any operations altogether. Now, so for the initial iterations, now let me just summarize you guys. So for the initial iterations, we have first iterate out to a size of k, and we have fixed our left pointer to as 0 and our right pointer to as k, and we have calculated our operations needed till this particular block. And now we will start another iterations for I equals to k, and we will go till I equals to n, and every time we will move our left pointer to +1 and we will move our right pointer to +1 to make the variables, so that is a fixed size sliding window, to make the sliding window size, because we have first, this for loop is basically making your sliding window size equals to k. So we have considered a sliding window size of k. Now when we are going to I equals to k to n, then on that times we are just maintain the sliding window by moving left and right pointer simultaneously, right? And what we compute, that logic we have already seen. If it is a black block, then add operations needed. If it is a black, then add operations needed +1 at right pointer. And if it is a white block, and if it is a white block at left, then remove operations needed minus equals to 1 when you are moving your left pointer. That's it. I guess you guys got everything. So yeah, let's go to the code itself. Then I can just quickly show you the code, and rest time and space complexity we will do, and then we can wrap this video. Yeah, so initially we have stating our need to perform operations as 0, and as I stated that we are moving our I pointer to k elements, and if it is a blocks of white, then we have to perform an operations and we are adding it to our answer, and we have starting our answer to be of size 102, because like for safety at max how many operations you are going to be performed, that is of as per the constant it can be at max 100, so anything's greater than 100 should work for your case. And now you can initialize your answer anything's greater than 100. So now uh, minimize your answer to answer, and first k consecutive elements, what is the operations you are able to calculate. You have done these minimizations. Now you set your left pointer at 0, right pointer as k. You are moving your I pointer from k to n, which we saw right here. So we are moving our, let me just saw you, so here it is. So we are moving our I pointer from k to n, and what we are doing, we are basically checking if it is a white block at right, then we are adding to our answer, and if it is a white block at left, then we are neglecting it our answer. So this is basically the backbone of your fixed size sliding window. If you understood what operations you have to do when you are incorporating a new value by your right pointer, and what you have to throw away when you are moving your left pointer, so if you get the like this on any particular question, what you have to calculate to by moving your right pointer or left pointer, then you are very good state to apply the sliding window on that particular question. Please go for that. That is very fine. So now you are next things is very intuitive. You are, what happened, we are moving our left pointer and we are moving our right pointer to making the sliding window fixed size. As it is a fixed size, we are making the block of chunks of k to every go. We are not going to be expanding our window and shrinking down, expanding and shrinking. That is not going to be applicable for this question. That is a, so fixed size sliding window is slightly easy compared to the variable size. Variable size is more things we need to be do. Yeah, that is a fixed size sliding window only, and after every operations you have to minimize your answer. What is the answer till you have it, and what is the answer for that particular block consideration you got, and then you are returning these things. Yeah, that is the most optimal time complexity of this question. And just quick time complexity analysis. The time complexity analysis, the time should be of this particular question is big of n only, because we are not doing anything. So this particular loop is going to be k, and from k we are again iterating to n. So the time complexity is big of n only. And do we think, you guys, we are using any extra space? Are we using any extra space? We are not using any extra space altogether. So the space complexity is also of big of 1. So that is the most optimal questions for this particular question. So that is the most optimal solution for that particular question. And you can saw this that I have submitted it, and it is taking off like very little time of 0 milliseconds. But yeah, don't rely on this Leetcode and this time limiter things. They are basically, if you are submitting the same solution multiple times, they are giving you a defined runtime on this same solution. So don't rely on this. But yeah, that is the most optimal and quite first solution that I just want to vent it out, guys. But yeah, and also that a quick things that this solutions is came to my wife brains. Yeah, she is basically preparing also for that interview, and she able to do this with big of n and big of 1. I initially by sawing the tag as easy, and then I basically saw the things of we have the choice things, then I go for this DP instantly. But yeah, she has done a great dive on this, and was able to find it with this most optimal fixed size sliding window. Yeah, hopefully I am able to explain you all the 3 approaches, and if you understood till this point, please do subscribe to our channel, and please hit the like buttons, and please make your very valuable comments to the comment sections. This is basically help we lot to improve our further contents. And yeah, that's all about today. And for the weekends we have couple of things. If you know, you know, otherwise you have to know because the videos are coming by today or tomorrow. As per the time permits, I will make the videos. Yeah, but that two things that I have already announced, that is for definitely coming to this weekends only by today or tomorrow. So yeah, till that, please do subscribe to our channel, and please provide your valuable comments. Let's meet tomorrow with new questions altogether. Okay, see you guys. Bye bye. Bye.